That's better. Right, welcome. So I'm going to talk today about audio and video processing, so with a focus on processing in HTML5. And on Wednesday I have another talk. Today my focus will be more on audio, and we're actually going to look at Mozilla Audio API stuff, which is why I'm wearing a Mozilla t-shirt today, in case you haven't noticed yet. I've put my Mozilla hat on. I was at the Mozilla Summit last year, and that's completely, totally fitting here, because the Audio API has this far only been implemented in Firefox. There is a competing proposal by WebKit guys of a audio API, which is a lot more filter based. This one's a lot more based on just pulling out the audio samples, and then you have to do all sorts of cool shit in JavaScript yourself. So I'm focusing on that today, because it's also been released. It's actually been released in Firefox, well, released, if you want to call Firefox 4 released. I've been running it for a long time, so for me it feels like it's a released browser. It's been included into a browser that's about to be released, whereas the API that has been developed in the WebKit community hasn't actually been put into a browser that's going to be released this far. They're still working on that, and nobody really knows yet what the standard ultimately will be for an audio API. But as I said today, I'll talk to you about the audio API of Mozilla, and I'll also talk about HTML5 video processing stuff. That will be mostly just showing of things. What I've done is, over the last year, I've actually written a book about HTML5 video, and it's basically a collection of examples on how to do things with HTML5 video. You could call it best practice, or you could call it recipes, or whatever you want. I'm going to give this book at the end of this presentation to the person who can make the best case for why he or she needs this book. So you've got a whole talk to think about something funny to say that'll make me want to give you this book. And I've got another 2 at home, so if there's multiple people giving good reasons, I might actually hand out more than one. So think about that while I give you the presentation. We'll get back to that at the end. A lot of the examples that I'm showing today are actually in this book, and I've also put them on a website, which is called html5videoguide.net. So if you wanted to check out some of these things, they're already publicly available. Plus, while we're at publicly available, my talk slides are already up here on blog.gingertech.net. On my WordPress blog in the uploads directory. I'll give you the link later, then you can put it on the website, unless you find it by yourself. Yeah, so if you wanted to follow along, you could follow us here. I've also tweeted about it, so just find my tweet for the link. Good, let's get into it. I call this Revelations about modern browsers, because to me, it's just amazing what's happening in HTML5 land right now. 20 years ago or 15 years ago, when I started research in audio and video content analysis, we did at the university, we did content analysis of audio and video. We tried to do face recognition. We tried to determine where there is advertising in recordings of radio, so we could split that out and stuff like that. And for the face recognition, for example, we put the program to work, and then we went and did some other stuff, and a week later we came back and looked at the results, and then we found out that we'd made some mistakes in our program, so we fixed them and so on. And after about a month we had something that was half workable and sort of did something of face recognition. And now the world's completely changed. It's just amazing. We can do it in the browser in real time. It's just honestly, I'm just off the chart. But let's get to that. We'll start with audio. So this is, for those of you who've never seen a video element in HTML5, this is what it looks like. Video, simple as that, just video, start element, end element, and a little bit of stuff in the middle. The source elements we had to introduce I say we because I'm also on the standards bodies involved and doing stuff. We had to introduce because it was not possible to get all the browser vendors to agree on a single baseline codec. And we'll not have that discussion here. That's a discussion for beer tonight if you want to talk about it. But I've not given up hope that it may eventually happen. WebM is a very good candidate for possibly eventually getting to a baseline codec. There's also all the discussions about real-time communication on the web happening right now, people wanting to do video conferencing. When you do video conferencing and one person uses Safari and the other one uses Firefox, you sort of need a common codec to do that. So it's actually, the problem has just become burning again, and discussions are flaring high on the standards bodies again. So we'll see. There might be something happening, who knows. So far, the pressure hasn't been too high because it's been a problem of the web page author, not so much of the browser. The browser could say, well, with the source element, if you author your web page properly and you put 2 files up, then you're fine, because one of these 2 will work, either, say, WebM and MP4 or OGG and MP4. One of these will work. So what happens then is a video element will be put on the page. This is a web page. All my presentation here is a web page, and I'm just showing off all the results directly here in my presentation. So that's the video. Any questions you have, please stop me. I'm on a roll here, so put up your hand and I'll put the brakes on and you can ask me questions. That stuff down there, that's just, that comes in when I mouse over it, is called the controls. And the controls are being put on automatically by the web browsers. So that's what this controls attribute does. Here, down here, this one. No volume allowed? Yes, there is. It's not implemented by browsers yet. That was actually one of the things I pushed for, that we need that we can put a muted attribute onto the video element, that we can get rid of the audio and just have the video play. If, for example, I want to play 5 videos at the same time and then use JavaScript to activate one as you mouse over, that kind of stuff, which is possible in Flash, wasn't possible before with the video element. You had to do everything in JavaScript. We're going to put an attribute onto it. The attribute is currently in the spec called audio equals muted, because people think that there might be other things we want to do with audio and video, but right now there's a change proposal and it might be changed to muted. It just doesn't really matter yet because that hasn't been implemented in any of the browsers yet, but it's trivial to implement.
Everything's basically exposed by JavaScript anyway.
Yeah, you could do it in JavaScript. And you can totally turn off the controls. If you don't use this controls attribute here, then it looks like this, and you can run your own controls through JavaScript. You just have to implement the API yourself, and the UI in particular. Anyway, that was video. This is what audio looks like. Very similar, of course. It's now called audio. And we can just turn it on. And this one is using the OGG file because I'm running Firefox. If you're in Internet Explorer 9 or in Safari or in WebKit, it'll use the MP3 file. Google Chrome, I don't actually know if it supports MP3. They're stopping support of H.264, but I'm not sure if they still support MP3. They probably do, actually. Anyway, let's get serious. And what we're doing now might get a bit more detailed than you might expect from an overview talk, because we're sort of doing a bit of a tutorial on how to do this cool stuff on the audio level here. So we're actually digging quite a bit into JavaScript, and this is where your question comes in actually really well, because you can control through these functions and variables. You can find out stuff about the video. So here, for example, is a play button. It'll hello play. Yes, of sorts. You can see at the bottom here, while it's playing, it gives media events, so that it started while it's playing, it goes through how often it's been playing, how many time update events are being thrown, and so on. So if I press the play button, you'll see that the time update, for example, walks up, and the current time changes. The current time down here is another media property that goes up as well. And so these are all the properties you can ask in JavaScript of the media element, or events that you can catch in JavaScript, or functions you can call, like load. So it's reloading the whole thing. You can see that it's just gone down to current time 0. You can go play, and you can go pause. These functions all work on the media element. Right? That's stuff that every single browser has implemented. That will work. Functions called like that, properties asked like that, and events are those codes, and you have to catch them as through a function call. I'll just follow this one for a moment, just to give you a bit of a feeling for where we're going now, because this is where the real fun starts. So we're doing audio processing, and yes, we've got a normal audio element here. I'm using the same example. But what if we could do then more than just press play? Yes, we get the audio sample. This is where the fun starts. What do we do with the audio sample? We display them. Bring with us in the time domain here. That's normal waveform display. Also, some filters on it. So, what was the question? Something about Safari?
You can, most browsers, you can press backspace to go back a page.
Yeah, well, this one went back to the previous offset in the page, but that's okay, because it's only one. It's a single index page, a single HTML page, but with fragments on them. Yes?
How horribly is it going to fail, like especially the swingy stuff at the end if you do it on Linux?
It should work. It should work on Linux.
It's not too bad at the moment. It mostly implements an OpenGL API, so it's not too bad.
Give it a try. Install Firefox 4 beta, and go to that link here. This link.
Depends how well your standard 3D graphics works. If your 3D graphics works fine, normally it'll work fine
and the developers, because I saw about one of the developers of the open source drivers that they're currently talking with Mozilla, going through and fixing up all the implementation right now.
So OpenGL, the Firefox 4 supports OpenGL, so the
But on Linux,
yeah, I don't know, but you can turn it on with the parameter. I thought it was working on Linux. Anyway, yeah. Anyway, go to that link. Find my tweet and find your way through if you can't read it fast enough. But what we're going to do now is we're actually going to learn how to do this stuff that I just showed you step by step. Sorry?
The slide link is on the...
It's on the web page now. On our website, yeah, the miniconf website. You can get it through there. Link all the way through, that's what the web's for. Anyway, so I've just shown you this bit here. Right? Pause. I don't know why it's not stopping. Obviously, the sound stopped. Yeah, I don't know. Anyway, I've shown you how to do this, but here's how really to do this, because we really want to learn the code, right? So what happens with the audio element in Firefox is that it exposes an extra event. The event is called MOS audio available. So as soon as there's an audio available, it actually can call this event listener, this function, and it'll give this function a frame buffer, which you get through the event data. And in this frame buffer, you get all the audio samples. This is really all we need in order to do something with the audio element. We need the samples, and then we can do all sorts of things. And here, all I'm doing is just displaying them, really. So the important line is this one here, to set up an event listener, and then to read the frame buffer out of the event data. So it's fairly simple. So the other thing you need to know about the samples is, of course, how many channels do they actually represent? What's the sampling rate, and therefore, and how long is our frame buffer? Ah, are you coming to give a talk? It's a lightning talk. That's good. Okay, so for the samples to be meaningful, you need this metadata, and there is also a function to read this metadata out of the audio. So Mozilla has added some extra properties on the audio element. It's called MOS channels, MOS sample rate, and MOS frame buffer length. And so these will give you everything you need in order to interpret your samples. You can, for example, as I did, calculate the duration in seconds by dividing the frame buffer length through the number of channels and the sampling rate. So we're pretty cool this far. And we can also get the times, so the event time, because, I don't know why. Because the time that our audio element is at may not be exactly the same as the time that our sample represents. So the sample that we're getting may be from the past, which you can see very much at the bottom. The audio element played till second 5.27, but the last element that we got was from the last audio sample we got was from 5.24 seconds, and the one before was from 5.22, and so on. I'm not displaying all of the samples, just always the first one out of the frame buffer, because otherwise it would get too much. Be flying by. So here, here you can see the current time is the time of the video element, so where the element is playing back, but the event has an actual time with it. So you get the time of the frame buffer, of the full frame buffer where it starts. And now you've got everything for the time. You know the time offset, and you know the duration of each sample, and all the other sampling rate and so on, and whether they're stereo or not. And so now we can do this waveform thing. that's my code to display the waveform. It's not quite as fancy as the others, but here you can actually see the wave of sorts, because I'm also not displaying all of the samples. But what I've done is here, I'm getting the metadata, the ones that are relevant, the frame buffer length and the number of channels, and then I'm displaying them. So here, I'm rendering the waveform, I'm getting the frame buffer, I've got 512 samples that I can display in my screen. The picture that I have is 512 pixels wide, so I only want to really get 512 pixels, and so I can calculate the step between the pixels, and I can start painting the waveform by doing a fill rectangle thing. This is something I should probably have mentioned. This is actually a canvas, and with the canvas, the way to paint into the canvas is by doing a path. So you put points into it, and what it does is it connects all of these points into a path, and that's basically what I'm doing here. So I'm starting at point 0. This is the data that I want to display, data point at point 0, and then I paint lines from that point 0, which is a path from every step along the way. I paint the next element. So this is the way to paint a very simple waveform, and you can do a similar thing with the full wave display that we had before. Right, so now we're getting the next step, which is the Fourier transform. Want to do this as well. So let's check out the code. Again, we're getting the metadata first, of course. Here, we're also setting up a Fourier transform, and I'm not going to show you the code of how to calculate the Fourier transform. You can find that yourself, and usually what we do is we just use a library that somebody wrote. I was very lazy. I used the library that the Mozilla guys developed, and just included that library, that JavaScript file. But we've got the channels, the buffer length, and the samples. And now, when the audio is available, we can write the samples. Writing the samples looks like this. This is a little longer, to be expected. Obviously, it does a Fourier transform. Here we first get the samples, but when we've got stereo, we actually have to do something with the samples. We have to use the two samples and average them. So the two samples of the two channels. So that's what I'm doing here. It's just a pre-calculation. Then we use the Fourier transform, and we put the signal through that. And then we display the calculated spectrum from the Fourier transform by, the first one is a zoom value, because otherwise they might be just very small. And then we're drawing rectangle bars. These are, you might remember, they're little rectangles here. That's a canvas, and the little things there, they're all rectangles. So we want to, we paint into the canvas this time. We paint little rectangles of size 4 pixels, and the height of the canvas, and from there just the magnitude of the spectrum. So this is how to do a little Fourier spectral display. It's not that hard. So from there on, you can do everything else. All the other examples are just another step on top of that. And if you wanted to find out, go to those pages, of course, because it's in the web browser. It's JavaScript. It's all open source. It's from Mozilla, so you can look at it and play around with it. Very welcome to go do that. And if you have any problems, there's a channel on IRC #audio API or something. Go Google for it, you'll find it. And the guys are very happy to provide support. They're really, really nice. So go and get started. It's really cool stuff. I also wanted to show something else that you can do. having seen Rose Garden before. We're sort of getting there with HTML5. I say sort of because this is basically just using samples that you can create and then throwing them back at the audio API for display. So you can not just pull out the data from an audio file, you can also feed it with samples. And that's what this one does here. So you can tell why I said it's not quite like Rose Garden. But it's getting there, it's doing the first step where it can actually play back audio inside, or synthesized audio inside the web browser. And they've done some nicer things than Twinkle Twinkle Little Star as well. Anyway, you get the gist. Check this out, it's really cool. You can do synthesis by throwing the samples back into the frame buffer, then giving the frame buffer back to the audio element. I should have put something in here, but I totally forgot. But it's described in here, how to do audio synthesis. Are you thinking about a reason why you want the book? We're halfway through the talk now. Sorry, I don't know how much time I have, but we'll just continue having fun. So now I'm moving on to give you a little bit of an impression of video, what you can do with video data in the web browser. And nothing in depth, we'll do that on Wednesday, but I'll just give you some demos here. So here, what you're doing is you're getting the individual frames out of the video and you're throwing them into a canvas, and from then on, it's basically a matter of manipulating pixels. And so here, for example, I'm just painting some tiles by moving the pixels around a bit, and it's the same video. It's just displayed as with some blanks in the middle, so tiled out, and just gives it a completely different feel and looks much bigger. So that's the kind of stuff you can do with video. You can pull the pixels out of a video, or the frames out of a video, throw them at a canvas, and then manipulate the pixels. Here, for example, I've used that to do a average color calculation, so that we've got on the outside we get sort of a ambient color around the video, making the video look just a little bit nicer and a bit fancy. So this is, by the way, the newest Blender film, Sintel, in case you're interested. You might want to check that out as well. So then another cool thing is how to do reflections.
The web's transformed culture, it's transformed the way we do commerce, it's transformed the way we do advertising, it's transformed the way we do entertainment, but science has been very little effective.
You're used to being able to get on the web and find relevant information pretty quickly, and you're used to being able to order books or other materials off of the web. But scientists can't do this when they're trying to cure malaria or to cure cancer.
When researchers, doctors do their research, what they end up finding is a lot of it is in separate silos. Some are private silos, and some are silos that have just been built.
A whole reflection underneath, and that's making it also a little bit more visually attractive to people to do that kind of thing. Here is something that that really goes into
the web's transformed culture,
video analysis.
It's transformed the way we do commerce. It's
here what I'm doing is I'm finding all the pixels that have a skin color. And as you can tell, it's got mistakes, and it's actually doing the same kind of mistakes with the people with different face colors. So it's pretty poor, but it's a first step towards doing something like a image face detection. So it's finding the pixels based on color, then it's grouping them and segmenting them, and that's how the square is being painted around it. Actually, in this case, I'm using web workers to help me do the the video analysis in a different thread to the main video. So I can throw just the frames into this thread. The thread will do all the hard calculation, and the main thread will not be stopped by doing all these hard calculations in JavaScript, which would normally deteriorate the video quality, and we don't want that. So it's actually a good application for web workers. Basically, web workers are threading for the web, and that's very useful for video analysis. And yeah, basically, we were obviously a bit more than halfway through, but I don't really want to go into all the details on how to do this stuff in video. I'll do that on Wednesday, the code, but I just wanted to give you a quick impression on the cool things you can now do with audio and video on the web. So thank you, and are there any questions? Any more questions? Or have I blown your mind? I hope I have, because I'm so excited about this. Yes?
Currently, what's the best way to do live video?
Live video. Live video on the web is, on the HTML5 web, is still a little bit difficult, because communication, video communication, Skype style, is actually not really possible. There is a device element which hasn't been implemented other than by Ericsson, I think, in a private branch of WebKit, and they actually have shown how to do video communication. But for video communication, you need to set up a connection, and you need to be able to get data off a device like a camera and stuff like that. So there's a lot of stuff still missing, which is being worked on. I would think that takes a few more years before we're there. Right now, what you can do is you can stream to a video element. You can basically live update the data that's going to a video element, because it just pulls it in from the source file, from the resource. And if the resource keeps growing, it will just continue pulling the data as well. In fact, the video element has deliberately been defined such that at the end it won't stop polling. It will continue to stop polling if there's more data coming. It will not go into a this is the end of the file kind of state. It doesn't have that. It actually goes into a pause state at the end, because there might be more data coming. But live stuff is just like real-time communication is something that's still a big challenge and still being worked on. No standards yet. Yes?
Probably a slightly simpler one. Is there anything for audio capture?
Yes. It's the same thing, because you need a device element as well. You need to communicate with the microphone being hooked up to the device. No different to Flash. No different to Flash. Oh, there will be like a menu coming up, and the menu asks you whether you want to provide access to the application to your device. So that's the way to handle this. You have control over it. But yes, you will never really get full privacy, the privacy issues around that. You can only really deal with that by asking the person. If the person gives access and then walks away and forgets about it, comes back and talks about private stuff, then it's basically their fault. There's not much the web can do, the standard can do. But yes, it's one of the big issues that's still under discussion.
How do you identify the device?
Sorry?
How do you identify a device that you're using this device?
So the web browser will have a device element, and there are certain interfaces that the web browser will get access to, like USB devices, microphone, camera, and so it will know all of these. It will bring up the list of devices that it knows about, and then you can say, these devices I want to use now. Something like that. Questions? Yes?
Is there a way to limit the amount of buffering?
Of the video?
Yeah. So, for example, in the player, normally when you play back, the browser will buffer
the whole thing
seconds before it starts to play anything.
Right.
But if you want to reduce latency, for example, it's a live stream, reduce latency, you can use into the browser. Please don't buffer that much.
It's not the buffering that will stop it from playing immediately. It needs to actually buffer enough data before it can play back. So it's a network issue as well. Yeah, but you are right. I mean, actually, all of the questions you're asking are very topical. They're actually very much the things that are being discussed right now. So one of the things with buffering that's currently being discussed is once you hit play on a browser, on one of the HTML5 browsers, the browser goes, oh, we need this file, we'll just download this file. So it goes and goes and goes and goes, and you only want to quickly put your nose into the video and find out, oh, what was that? Oh, I don't really want to watch it. And then you go away and the browser thinks, I think they will continue to watch this video, so we will just download the whole movie. And so it's 10 minutes later, because you've downloaded a half-hour video, you come back and you downloaded the whole video, but I don't really want to watch it anymore. So that's actually bandwidth use, and the user isn't that much concerned about the bandwidth use, because normally users have enough. Some users are, but it's not like really disastrous. What's actually disastrous is for the service provider, because of course they have to pay for the bandwidth as well. They provide the video data to the internet, and they pay for it. And there's a lot of service providers, video providers, that have come back and said, we have to manage this. We have to actually stop the video from downloading too far ahead from the current play time, because we have to pay for that data, and we don't want to pay for that data. So either put a JavaScript function in there where you can stop it from buffering, or put a better strategy into the video element where it doesn't buffer all the way through. And so that's currently actually under discussion. So there will be something coming in into the video element, some further spec, and some new development. So we have to be aware that there will be issues with the video stuff in HTML5. Just like there have been issues with Flash but Flash had 10 years to fix all this stuff. We're getting there with the HTML5 video and audio elements. It's actually making huge progress. Yes?
Really clear on the sort of how HTML5 standard is progressing. Is this, are these new things going to be 5.1, or is this still under discussion?
So about the specifications, we're currently in the W3C in a state where we're basically wanting to finish off on new functionality by about, I think, March or something. There won't be any new functionality going into HTML5. That will be called HTML5, and up until and from there on, it's about implementing this and about fixing bugs, both in the spec and in the browsers. But that's the W3C world of the view of the world, where a spec will be finished and there'll be going a stamp on it, and we call this HTML5. So everything we do after that will be called HTML6 probably. Whether that's the way it will actually be, I don't know. But there's definitely stuff that's out there that might not make it into the spec before March. And I think what working group's view is probably more open, as in this is a living standard, we'll continue to add stuff to it. Whether we call it HTML5 or HTML6 doesn't really matter. So I think what's going to happen is we recognize that there are issues, just like in a open source project, we will continue to develop new things, and we make a release at some point, and so then afterwards we put more features into it. And the same thing will happen with HTML5. Whether it's then called HTML 5.1 or HTML6 or whatever, it's just basically continued development. Yeah. You had another question?
You mentioned that the video element keeps polling for more information.
For more data, yeah.
Is the audio element similar? Does it continue polling once?
Yeah, they both do that. When I say video, I actually mean media. So I should say media.
Common element, really, just the video one has a video component to it.
Yeah, basically. I'm not sure. It's probably implemented in a very similar way. In some browsers, it's actually using the same media framework underneath. For example, Opera uses GStreamer as far as I know, so for Opera it doesn't really matter if it's audio or video, it just throws it at GStreamer. there is one difference which I found a little bit difficult to understand at first. The way that captions have been specified is that captions will only appear on video elements, not on audio elements. But that means all you have to do is you have to throw your audio file into a video element, which gives it a visual component, and then you're displaying captions on your audio element, but it's got to be a video element that you're using. It's on your audio resource, but it's got to be a video element for presentation, if you're following me. That's because audio, in essence, doesn't really have a visual component. It might have controls, but if you don't put controls on, then it's something virtual. It doesn't really exist on the page, not visually. So you can't put captions onto something that doesn't have a visual component. And that's why it's got to be through a video element, which makes sense from that point of view. Yeah?
Have I understood properly that the implementation that Firefox uses of the audio to video element is GStreamer? Even on
Not Firefox. Firefox have their own implementation. Firefox have developed their own audio and video libraries. Well, they used...
So in one way, Opera is kind of more open source in that area than everybody else?
No. Yes and no. So it's all Firefox is open source anyway. So everything in Firefox is open source anyway. So you couldn't really say one is more open than the other because they're both open source. But Firefox have made a conscious decision not to go with an existing media framework. Because if you go with a media framework, then the media framework will support a lot of other codecs as well, and you'd have to manually turn off the use of those codecs if you do not want to support them in the browser. And there's all sorts of consequences. Opera is having to deal with other issues than Firefox. Because, for example, also with the audio devices on the different platforms, they can't do it themselves. They will go through GStreamer and then through, I don't know, Pulse Audio and whatever, I don't know. But Firefox is going more directly. It's a matter of taste whether you prefer one over the other. I think they both have advantages and disadvantages. Since Mozilla is everything open source anyway, I mean, you can look into what they're doing.
I mean, it's not about open source or not, it's just about being nice. Like, not re-implementing it is something we've already been discussing.
As a browser, they don't need the full framework. I don't know. Let's not have that discussion. So, any more questions? All right. Well, we'll get to the last bit here. I have a book for you. It doesn't have my signature yet, but I'll sign it if you want to. I'll even put your name into it, whoever it will be. So if you thought of some reason why you'd like to have the book, and we should probably hand out the microphone. Yep. Do you want to do it? Yeah. Thank you. Let's hear the cool things you've come up with.
Who wants a book?
Nobody wants the book.
So rather than just embedding an audio in a video device, what about doing something like embed, say, dev TTY, so I can get serial console access via a web browser? Is that going to be easier in HTML5?
I don't know. That's a device question. To be honest, I'm a little bit out of my depth there because I'm only really focused on audio and video. But it might be possible through the device element, yeah.
Between the WebSockets and WebWorkers, you could sort something out, but you have to still have a supporting application on the server side.
Might be possible to do through some sort of plugin or something.
Yeah, you could have an alternative. Yeah, alternatively, you could have a plugin for a local device, but there's still nothing in the HTML spec for accessing local resources.
The only real local resource access is through device element, and that's by far not solved.
I would like the book because I'm interested in, if it's possible, to create a audio sensor so I can detect if someone has intruded in the house, or a light sensor to detect if someone has left a light on in one of my rooms. So that would be something which I'll be interested in doing by reading your book.
That is very cool, but you will also have to wait for the device element. That is indeed a very, very cool application. Yeah. With but not with HTML5.
All right.
Here, there was another.
There's another one?
Yeah.
Two things. One is I'd love to get rid of all the crappy little video JavaScript things we've got floating around to try and control video, YouTube style, and Flash elements we've got in our software. And secondly, and this is based on some really cool thing called Anadex, which I'd love to be able to implement someday, and maybe some of this helps there. I was actually going to ask that as a question. Is there stuff in this that you could use to help implement Anadex?
We're getting there, yes.
Cool.
So one of the big things, and I'm actually going to talk a little bit about it in the lightning talk, one of the big things that are happening right now is timed tracks, which means you can time synchronize text with the video. Captions and subtitles are an obvious case. Another thing is text descriptions. Descriptions are really for the vision impaired people. So if you have a text description and it's being read out by the screen reader, then you can actually have blind people essentially partake in video watching, which is really cool. So that's what I'm working towards actually on a contract for Mozilla and also for Google. And that's one of the key things I want to still get into the standard before the May or March or whatever cut-off time. So there's quite a bit of work to be done still. But through that, there's also a thing called a metadata track. And a metadata track is time-aligned text that can have anything in it. It can have a JSON object in it. It can have marked up HTML in it. It can have anything in it. It's just basically a time fragment with some associated text. And you get that into the JavaScript through an API. So when you get it into JavaScript, you can do whatever you want with it. You can display it on top of the video. So this way you can get hyperlinks into the video at the right time and display them on top of the video. And that's basically what Anadex was doing, linking out. And linking in is happening as well, because we're doing in the W3C, there's a media fragment working group, which I've been working with for the last 2 years. So we've standardized how to do hyperlinks into videos to certain time offsets. So that's already a standard. And the media element is supposed to support that as well. So if you put a URL into the media element that has a time offset, it is supposed to just play that time offset or start playing at that time offset. So that's happening. That's all happening. It's very exciting, obviously, because I've done Anadex before, and so yeah. But you mentioned before the first thing.
We use a lot of JavaScript widgets to control video.
Right. In what context? Oh, can you talk about it? Surveillance video. Oh wow, interesting. Cool. Has anyone else got a use for the book? Yes? The book.
You really need to give this book away.
The Bible.
So at the moment, in what we're doing, we're using WebGL to render a mesh that's derived from depth data coming from Xbox Connect. What we would like to do, though, is texture it with the live video coming from the Connect. So maybe the book has some sort of...
Is that for an open source project?
No.
Oh. Sorry, you just went down from... It would preferably be an open source project that I'd like to give this book to. There's more, sorry. Am I taking away time?
Yeah, we need to sort of wrap this up probably, but...
I could just shout the question out.
Yeah, just quickly.
Whether there was an electronic version of the book.
There is an electronic version, but you'd have to buy that from Amazon. Unfortunately, I did not get a copy. So what happened, I did a search for my book, and there's some links to PDF files that are already floating around, so you probably find one. But it's actually much more worth it to have it in paper form.
Do you reckon you could get it to work well with live streaming, perhaps? in the future?
Yeah, well, live streaming, as long as you don't need the device element, if you're somehow getting it onto the server,
files.
and yes, that will work.
Awesome.
Works today, yeah, works today.
What about video editing?
Yes, there's been somebody has implemented already a kind of a video editor that nonlinear video editing with a HTML5 video element, because you can do all sorts of seeking and stuff on it. So yeah, that already exists. Somebody at Wikipedia is experimenting with that. Michael Dale, actually. Yeah. Okay. I think you're getting the book. Making a lonesome decision here, but come to me and I'll sign it to you.
Okay.
Thank you very much, everyone. Hope you found.